This is probably an unlisted video on my channel. It's about the analog to digital converter, and basically I'm reading the data sheet so that I can understand some basics and even get the text into the transcript so I can use it. And I need to do some groundwork to understand this properly to make a subsequent video on it. Something that will be public in my series of videos on the PIC 18F4525. So anyway, now that's almost a minute. Maybe I want to timestamp this about right now, because I'm going to start reading at, well, let's wait another minute till it's a minute. Okay, at 1 minute. AD conversions. Figure 19. Oh, this is on page 230. Figure, and note to self to put the data sheet in the description. AD conversions. Figure 19.4 shows the operation of the AD converter after the go done bit has been set at the ACQ2 QT2 ACQT0 bits are cleared. A conversion is started after the following instruction to allow entry into sleep mode before the conversion begins. Figure 19.5 shows the operation of the AD converter after the go done bit has been set and the ACQT2 and ACQT0 bits are set to 010 and selecting a 4 TAD acquisition time before the conversion starts. Clearing the go done bit during a conversion will abort the current conversion. The AD result register pair will not be updated with the partially completed AD conversion sample. This means the addressal registers will continue to contain the value of the last completed conversion or the last value written to the addressal registers. After the AD conversion is completed or aborted, a 2 TAD wait is required before the next acquisition can be started. After this wait, acquisition on the selected channel is automatically started. Note, the go done bit should not be set in the same instruction that turns on the AD. Discharge. The discharge phase is used to initialize the value of the capacitor array. The array is discharged before every sample. This feature helps to optimize the unity gain amplifier, as the circuit always needs to charge the capacitor array rather than charge discharge based on previous measure values. AD conversion, TAD cycles, ACQT thus. And there are these charts. And it's complicated, it looks like. Yeah, I can't even begin to understand this. An AD conversion can be started by the special event trigger of the CCP2 module. This requires that the CCP2M3, CCP2M0 bits be programmed as 1011 and that the AD module is enabled. ADON bit is set. When the trigger occurs, the go done bit will be set, starting the AD acquisition and conversion, and the timer 1 or trigger 3 counter will be reset to 0. Timer 1 or timer 3 is reset to automatically repeat the AD acquisition period with minimal software overhead, moving address and addressal to the desired location. The appropriate analog input channel must be selected, and the minimum acquisition period is either timed by the user or an appropriate TACQ time selected before the special event trigger sets the go done bit starts a conversion. If the AD module is not enabled, ADON is cleared. The special event trigger will be ignored by the AD module but will reset the timer 1 or timer 3 counter. Registers associated with AD operation. Comparator mode. The analog comparator module contains two comparators that can be configured in a variety of ways. The inputs can be selected from the analog inputs multiplexed with pins RA0 through RA5, as well as the on-chip voltage reference. See section 21.0, Comparator Voltage Reference Module. The digital outputs, normal or inverted, are available at the pin level and can also be read through the control register. The CMCON register, register 21, selects the comparator input and output configuration. Block diagrams of the various comparator configurations are shown in 21. Common comparator control register. I almost want to abandon the whole thing. Shouldn't talk like that. Just to understand this.